Okay, good afternoon class. Okay, so for today we will continue with the multiple linear regression. Okay, so in the assessment, lab assessment, there will be a question related to the multiple linear regression, right? Okay, so for the linear regression, you must make sure that the independent variable and dependent variable is a quantitative. Okay, so what is your data? No, I mean overall. So if your data have the dependent variable 0 or 1, this is a binary logistic regression. Okay, but then in the question, they ask you to do the multiple linear regression. Okay, multiple linear regression, the y or dependent variable should be in the quantitative. Okay, so if you have your data already, okay, if you have your data already, and then your data is have a binary dependent variable 0 or 1, so you proceed with the binary. Okay, because it takes time for you to change the data. Okay, right, so we will have a multiple linear regression and also the binary logistic regression. Okay, but then you'll be able to explain the binary logistic result. Okay, alright, so I give you chance, okay, because that one you are supposed to have a data that all have a continuous and quantitative, right? But some of you might not aware that if your dependent variable is 0 or 1, you cannot proceed with the multiple linear regression. Okay, so we change a bit the topic, which is regression analysis, not the multiple linear regression. Okay, but then you cannot do the simple linear regression. You must do the multiple linear regression or binary logistic regression. Okay, alright, so for today we will continue with the multiple linear regression. Okay, so for the part 2, you can submit on next week, Tuesday, 17 December. Okay, before 12 AM. Right? Okay. Alright, so for the multiple linear regression is actually extension of the simple linear regression, whereby for the simple linear regression it is only involve one independent variable, and then it is also involved with the one dependent variable. Okay, however, for the multiple linear regression, we will involve with the 2 or more independent variables to the one dependent variables. Okay, so this is basically the situation of the multiple linear regression. Okay, so let's assume that you are a small business owner, okay, for original delivery service, okay, who offers same-day delivery for letter, package, and also other small cargo. Okay, you are able to use the Google Maps to group individual delivery into one trip to reduce the time and fuel costs. Okay, therefore some trips will have more than one delivery. Okay, so as the owner, okay, as the owner, you would like to be able to estimate how long is the delivery will take based on the 2 factors. Okay, so this is the situation related to the multiple linear regression. Okay, we increase, and then we have an additional independent variable. For example, like the total distance of the trip, okay, and also the number of delivery. Okay, probably that you have few number of delivery per day. Okay, so you see that here we do have 2 factors for this regression. Okay, we do have 2 factors for this type of regression. Okay. Alright, so for this multiple linear regression also we take a random sample of the data. For example, like for this one we have the, to conduct the analysis we take a random sample of 10 past trip, okay, and record 3 pieces of the information, okay, for each trip. Okay, so for example, like we have miles travel, okay, the distance you travel. Alright, so the number of delivery will be the second factor. The first factor is a distance travel, and the second factor is the number of delivery, and then this one, y, is the travel time. Okay, so basically we have 3 pieces of information, but 2 are from the independent, which is x, and then another one is from the dependent, which is from y. Okay, so this is what we call as a multiple linear regression, right? Okay, so in this case, based on this data, okay, we recognize the dependent and also independent variables. Okay, so we would like to predict the total travel time, okay, using the both of the miles travel and the number of delivery on each trip. Okay, so we have 2 factors, and also we want to estimate. Okay, that is why the regression analysis is can be known as a estimation model. Okay, all right. So in what way does the travel time depend on the first two measure? Okay, the travel time is depending on the first two measure. Okay, so the first one is we have the dependent variables. Okay, we call it as a response variable, and then we also have the independent variable. We call it as a predictor or explanatory variables. Okay, all right. Okay, so basically this is a simple theory. Okay, so multiple regression is an extension of the simple linear regression. Okay, all right, this is an extension. Right, so simple linear regression, we only have one independent variables, okay, and then we also have one dependent variable, one x and then one y. But then for the multiple regression you will involve with the two or more independent variable and also one dependent variables. Okay, so this is basically the model for the dependent variables. Okay. Alright, so under the multiple regression, we always need to check first is the correlation. Okay, correlation between the dependent variable and also independent variable. Okay, whereby we always expect that the independent variable, the first independent variable with the dependent variable has a strong relationship. Okay, and then the second independent also have a strong relationship with the dependent variable, but never we expect that the independent variable has a correlation. Okay, that is why we call it as an independent variable. They shouldn't have any correlation. Okay, why? Because if we have the correlation between the independent variable, then the problem multicollinearity. Okay, the multicollinearity will be in our model, which is we expect to avoid the multicollinearity in our model. Okay, all right. So there will be two. Okay, there will be two problem or issue under the multiple linear regression. Okay, for this module. All right. So the first one is overfit. Okay, overfitting the regression model, and the second one is the multicollinearity. All right. Okay. So based on this justification, they said to you is adding more independent variable to a multiple regression procedure does not mean that the regression will be better or offer better prediction. Okay, in fact it can make things worse. Okay, for example, this one is we call it as a overfitting. Okay, why? Because sometimes the independent variable does not have a significant effect to the dependent variables. Okay, but then you just include into the model, so that one doesn't bring any impact or effect to the y. Okay, so that is why we call it as a overfit. You overfitting the regression model. Don't you simply put the independent variable that are not having a significant result or significant impact to the model. Okay, alright. So normally the overfitting arises overfitting happen when there are too many number of predictor. Okay, you are considering too much number of the independent variable, okay, approaching to the number of observation. Okay, all right. So for example, like number of observation, let's say you have 50, n is equal to 50, p maybe you put 40. So maybe the problem of the p is a number of the explanatory variable. So maybe this one will lead to the problem of the problem of the overfit. Okay, because some of the significant independent variable are not being filtered out from this model. Okay, all right. Okay, all right. And then the addition of the more independent variables create more relationship among them. Okay, the independent variable related to the dependent variable. Okay, the independent variable potentially related to each other. Okay, all right. So another thing is you cannot simply put so many independent variables because you want to avoid any of the multicollinearity problem. Okay, so when you include few or maybe you include 10, maybe 11, 12 of the independent variables, okay, they will affect in terms of the multicollinearity. How? They will correlate to each other. Okay, they are correlated to each other. Okay, all right. So the ideal one is for the independent variable to be correlated with the dependent variable. Okay, the ideal one is we always want to check for the correlation between the independent variable and also the dependent variable, not between the independent variables. Okay. Alright, so how are you going to check for the multicollinearity in your model? How to check? How to measure? Correlation, multicollinearity. How you know that your model has a multicollinearity problem? Using the what measure? VIF, right? Variation inflation factor. Okay, so if you check if the variation inflation factor, okay, alright, variation inflation factor, okay, if 0 means that there is no multicollinearity in your model, which means that the independent does not correlate to each other. However, if the VIF is greater than 5, the value is greater than 5, okay, so what will happen? So means that they are correlated. The independent variables are correlated to each other. Okay, means that the problem of collinearity in the model. Okay, and then if the problem of the multicollinearity exists in your model, that will affect the regression coefficient. Okay, and then regression estimation as well. Okay. Alright, so preparation. Before you are using this one, okay, before you are using this one, we need to prepare. Okay, how to check for this one? Okay, how to check, how to make sure that our regression model are very efficient. Okay, the first one you need to check the correlation. Okay, correlation make sure that the correlation, the strength of the correlation is high between the independent variable and also dependent variable. Okay, the second one you can check by using the scatter plot. Okay, this one is a graphical one. Okay, but then if you between these two, scatter plot and also the correlation, we prefer to use the correlation. Why? Because they provide you the numerical value or numerical measure. As compared to the scatter plot, they just provide an graphical, so you can observe only. Okay, it's better. You can check your scatter plot, but then please confirm with the numerical measure. Okay, you check normality by using the histogram, but then the most effective way is by checking with the Shafiro-Witt test. Okay, and then you have done the simple regression. Okay, just a simple regression like one variable and also one dependent variables. Okay. Alright, so this is the multicollinearity. Okay, so maybe multicollinearity exists when the X1 and also X2 are correlated, whereby we don't want them to be correlated. We only want X1 and Y, X2 and Y to be correlated. If X1 and X2 correlated, means that this one is a problem of the multicollinearity. Okay. Alright, so we proceed with the model of the multiple linear regression. Okay, so the model will be the same. Okay, the same like the simple linear regression. Y is equal to B0 plus B1 X1 plus EI. Okay, this one is for the simple linear regression. Okay, but for the multiple linear regression, we have Y, we have B0. B0 is equal to Y-intercept, okay, plus B1 X1 plus B2 X2. This is the first independent variable. This is the second independent variable. Okay, maybe you have 3 independent variables until the last one. Okay, this one, because each of the model will be different. Okay, your group will be different from other group. Okay, so you might consider how many independent variable depending on your study. Okay, alright, so B1, B2 and so on are the parameters, and the E epsilon is the random error. Okay, so same also. Same with the simple linear regression, you need to estimate this parameter coefficient. You need to estimate this one. Okay, from the previous, we estimate this one by using the OLS, right? Ordinary least square method. Okay, but then for today, you cannot simply this one. Okay, because this one will be complex mathematical calculation, so you need to use the programming. Why? Because later it will be like matrix. Okay, matrix 10 by 10 is okay. How about matrix 10 multiply 100 multiply 10 and so on? We don't know. Okay, so that is why for this one there is no calculation, manual calculation, but then we rely on the tools, okay, R tools for the calculating the coefficient parameters. Okay, coefficient parameter for this one. Okay, so this is the estimate. Okay, you will estimate by using this. Okay, y hat is equal to b0 plus b1 x1 plus b2 x2 plus bp xp. This one is you going to estimate all the parameters there. Okay, right? Similar with the simple linear regression. However, multiple linear regression you will use the R. Okay, because the computational for this one is involving the matrix algebra. Okay, so if you know matrix, then you can proceed. Okay, alright. So, but then for this one, I advise you to use R. Okay, alright. So basically, this is a estimation process for this regression. Okay, so the first one is the multiple linear regression. So we have this one, expected of y and so on. Okay, and then this is the regression model. Okay, and then we take the sample data. Okay, after we take the sample data, we use the estimated the multiple regression, and last one we estimate this one. Okay, alright. So for this multiple linear regression, it is also involve the what? Involve the hypothesis testing as well. Okay. Right. Okay, so for this one, they said to you computation of the coefficient values. Okay, the formula for the regression coefficient B0, B1, B2 until the BP, the last independent variables. Okay, involve the use of the matrix algebra. Okay, they are involving the matrix algebra. Okay, we will rely on the computer software package to perform the calculation. Okay, so after this, please ask where the formula for the multiple linear regression. Okay, but then for the simple linear regression, we can do the manual calculation. Okay, because it's only involve the few variables. Okay, and also based on the number of observation. If large observation, okay, so maybe you need to use the R programming also. Okay, right. Okay, so we proceed with the example. Okay, 5 minutes break before we proceed with the example. So class, for the final, okay, for the final, because this one is a week 12, right? Okay, so the topic cover for the final is introduction to statistics and also the measure of central tendency. Okay? Huh? Not only 2. Okay, next week another 2. Okay, you finish study this one first. Okay, next week will be 2. And then week 14 we have a break 1 week, right? Okay, alright. Okay. For those who didn't do the TES, okay, please complete the TES. Okay, you complete the TES and then another 2 topic will be unlocked next week. Okay, study that one first, okay? Study that the measure of central tendency and also study for the introduction to statistics. Okay? Okay, so class, we continue with the example. Okay, all right, example for this multiple linear regression. Okay, a health researcher wants to be able to predict the VO2 max, okay, an indicator of the fitness and also health. Okay, so a researcher recruit for the 100 participants to perform a maximum VO2 max test, but also recorded their age, weight, heart rate, and also the gender. Okay, so you see that there will be involving few independent variables. Okay, heart rate is the average of the last 5 minutes. Okay, of 20 minutes. Okay, much easier, lower workload and cycling test. Okay, all right. Okay, so the researcher goal is to be able to predict the VO2 max. Okay, based on these 4 attributes. Okay, so the first one is the age, weight, heart rate, and also the gender. So this one is related to the fitness and also medical, right? Okay, so they want to predict. Okay, they predict the VO2 max based on these 4 attributes. Okay, predict is always one variable only, one dependent variable, and then they also consider does the age will affect the VO2. What is VO2 class? VO2 max. Anyone here from the fitness? Okay, all right. So VO2 max based on the age. Does the age will affect this value? Okay, does the weight and the heart rate also affect the VO2 max or not? Okay, so that's mean of the regression analysis. Okay, all right, so we see this one. Okay, this is the result or the output when you use the programming. Okay, but then this one is from the SPSS. Okay, this one is from the SPSS. Okay, but then if you use your R, okay, they will provide the same result for this. Okay, we have the R, we have the R square, we have the adjusted R square, and then we have the standard error. Okay, right, so how you gonna interpret this one? Okay, because the coding is similar with the simple linear regression, only you plus for the additional independent variables. Okay, all right, so for this one is based on the R. Okay, so the R is representing the multiple correlation coefficient. Okay, multiple correlation coefficient, R can be considered to be one measure of the quality of the prediction of the dependent variable, in the case VO2 max. Okay, so what is the value of R? R is for the multiple correlation. Okay, you get 0.7. So what indicates from the 0.75? Is good or not? Okay, it's good. Okay, it's the higher the value is better. All right, and also we have the R square. You should be able to explain the R and also the R square. Okay, the R square here will be coefficient of determination. Okay, so R square is based on the R, and then you put square, whereby this one you get the 0.76, 0, and then you put the square. Okay, the R and R square will be the same. Okay, all right, so the R square is a value for the coefficient of determination. Okay, so it's the proportion, okay, proportion of the variance in the dependent variable that can be explained by the independent variables. Okay, all right, so technically it's the proportion of the variation accounted by the regression model above and the beyond the mean model. Okay, so this one, what is the expected value? Okay, how this one? This one also used for the accuracy, right? How the model, okay, how the regression model fit the actual data. Okay, how the model fits the actual data. So possibility of the higher value might give you a good result, okay, or indicate a good result of the regression. Okay, so you should be able to explain the R and also the R square. Okay, for this one. Okay, later you will see the output for the R. So we have the R and also the R square. Okay, so independent variable here, we consider this one. Okay, this is the estimated model coefficient. Okay, estimated model of coefficient, whereby we do have the Y. Y is the predicted VO2 max, the volume of the VO2. And then we also have the Y-intercept. Okay, Y-intercept. And then this one is the first Y-intercept. Okay, the first independent, the second independent, the third, and the fourth independent. Okay, so for this case, we will take this one, unstandardized coefficient. Okay, all right, so normally before, okay, normally before we use the ordinary least square method to get all these coefficient. But, okay, by using the R, okay, they will provide you this one, this value. Okay, so the coefficient you need to take this one. What is a B1, what is a B2, what is a B3? Okay, each of the regression coefficient for each independent variables. Okay, for example, we have the constant here. What is constant here, class? What is the constant there? Okay, 87.83. So this one is for the y-intercept. Okay, y-intercept is happen when the x is equal to 0. Okay, and then they consider the age will be the first independent variables. Okay, so that one is a B1 x1. Okay, and then you can see that the value is a negative value. So 87.83 minus with the 0.165. Okay, following the regression coefficient. And then we also have the heart rate. Okay, heart rate is equal to negative 0.118. Okay, 118. So you just replace all this value in this one. Okay, replace all the value in this one. Okay, in your case study, if you conduct a linear regression also, please write this model. Okay, you need to write this model in your case study. Right? Okay, right, so we also have the standard error. Standard error is always, we expect that the value will be smaller, like the standard deviation. Okay, the value must be smaller. Right? Okay. So we see here the coefficient for the B1 and so on. Okay, take all the value here and then plug in all the value into the regression model. Okay, like we do the simple linear regression. Okay, so what is the definition of the negative 1.65 here? Negative 0.165 here. Okay, so you can check from here, this one. Okay, alright, so for example, the unstandardized coefficient B1 for age is equal to negative 0.165, okay? This means that for each 1 year increase in age, okay, 1 year increase for age, okay, will be decreased in terms of 0.165. Okay, why decrease? Because there is a negative, okay? So because the B1 interpretation is any 1 unit increase in terms of B1 will affect the decrease or increase in terms of dependent variables. Okay, alright, so based on these two, you need to refer from this. Okay, you need to refer from this and also from the simple linear regression. Okay, check for the simple linear regression interpretation. Okay, so what is the interpretation based on the coefficient, and then what is the interpretation based on the B naught? Okay, B naught is a y-intercept. Okay. Alright, so we take the unstandardized. Okay, even they provide you the standardized and also unstandardized, you just take the unstandardized. Okay. Alright, take this value. Okay. So you see this one. Okay. The third one, what you can interpret from this one is a statistical significance of the independent variable. Okay, possibly not all the variable that you include in your regression model are not significant to the change of the y. Okay, maybe the age does not affect the changes in terms of volume of the VO2 maximum and so on. Okay, alright, so how to get this one? You can check from the t value and also you can check from the significant. Okay, so we know that from the significant, any the p value less than alpha 0.05, so means that what happened to this p value less than alpha means you reject the h null, right? So means that the variable is very significant. Okay, so we check here. Okay, this one, the significant is a 0, 0, 0, so means that it's very significant. Okay, because this is a less than p value. Okay, and then we can check all. I think all is 0, 0, 0, right? Okay, and then we only have one, 0.01, also less than 0.05. Means that you will reject the h null. Okay, if you reject the h null, means that all of these are significant. Okay, all of these are significant in your study. Okay, so what is the t means? Arifin, what is the T means there? What is the T value means? What happens if the T value increase? Normally when the T value increase, the value of the significant will decrease, okay? Alright, so it will be correlated to these two, what we call these two measures. But then most important part is you can take from the significant, okay? Alright, so from the significant here. Okay, alright, so since this one, okay, this one is the, we have also the 95% confidence interval, okay? 95% of the confidence interval, so that one is the 75 until 100, okay? 75 until 100, and the value will be, what is the value here? 87. Okay, so that one is a, we reject the H null, okay? Wait, yeah, this one. Okay, make sure that you have these two. Okay, when you explain in your video, okay, and also you explain in your case study, make sure you explain this significant. Okay, which of the variables are very, very significant to your study, okay, based on the P value, okay? Alright, so you can refer to this, okay, you can see from the significant column that all independent variable coefficients are statistically significant, different from the zero. So, okay, this means that all the variables are important, okay? Sorry? If the value of the significant is less than 0.05, means that you will reject the H null, right? So you reject the H null means that okay? Okay? So this is for the hypothesis testing, okay? Hypothesis testing H null is not significant. There is no significant correlation, there is no significant parameters and so on. And then H1 is the significant parameters, okay? So if the P value less than alpha, so you will reject this one. So you only see this significant. Means that all the independent variables are very significant in your study, okay? Okay? Right, okay. So a conclusion is a multiple regression was run to predict the VO2 max and so on from the gender, age, weight, and also the heart rate, okay? So this variable is statistically significant predicted in the model. Why? Because the P value is less than 0.005, okay? Alright? So all four variables are added significantly in the model. Okay, so you make sure that all the value are significant. Okay, but then if you found that the P value is greater than, means that that one is not important. Okay, or not significant, not having any significant impact to the dependent variables. Sorry. So you can proceed doing the R and also the video for your part 2. Okay, can submit on the next Tuesday. Okay, so what you need to have is you can explain, you're able to explain the R here, R square, and also this one. This is very significant. This one is very important. The significant and also the unstandardized, the coefficient. Coefficient also important. Why? Because from the coefficient also you can predict and estimate the future. Okay, the future for this case. Okay. Okay. Alright. So since tomorrow is a public holiday, so maybe tomorrow I will provide few on the coding. Okay, and then I upload on my times. Okay. I think the coding is simple, right? Pavitra, you have done the coding? What is previous one? What is the previous? I think the coding in R is like this, right? LM. And then this one is we have Y. This one X1 plus X2 plus X3 data, right? Okay, they will provide you the result, okay? Just plus because this one is an extension of the independent. Okay, it's just extension for the simple linear regression. Okay, the way you will write for the explanation also the same, interpretation also the same. Okay, all right. So for the final, okay, introduction to statistics and also the measure of central tendency means that you need to attend the next week class. Okay, all right. So anything to ask for the case study and also lab assessment? Okay, so if you wait, I just give this one. Okay, all right, that's all class for today. You may take the attendance. For those who have questions, okay, I'll be here until 4. Okay.